Have you ever looked up at the sky, seen a massive airplane gliding effortlessly above the clouds, and thought, how is that possible? How can something made of metal, weighing hundreds of tons, stay in the air? It seems almost magical, and yet it isn't magic at all. It's pure physics. For the next 20 minutes, we're going to uncover the hidden science of flight, from Bernoulli's Principle to Newton's laws, and by the end, you'll never look at an airplane the same way again. Before we take off on this journey, let me ask you, do you enjoy discovering the hidden science behind everyday wonders? If yes, make sure to like this video, share it with your friends, and subscribe to the channel right now. Because every week, we explore mysteries that are hiding in plain sight, and you don't want to miss them. Now let's dive in. Imagine holding a rock in your hand. If you throw it into the air, it comes down almost instantly. A football, even lighter, arcs and falls. But an airplane, thousands of times heavier, can soar for hours. How is that possible? The answer lies in lift, an invisible upward force that balances gravity. And lift is created by none other than the wings. But here's where the story gets fascinating. Airplane wings are not flat. They're curved on top and flatter underneath. This special shape is called an airfoil, and this is the key to flight. As the airplane speeds forward, air splits into two paths, one going above the wing and one going below. Because the top is curved, the air has to travel farther in the same time, which makes it move faster. And here's where Bernoulli's Principle comes in. Bernoulli's Principle says that when air moves faster, its pressure decreases. So, the air above the wing has lower pressure and the air below the wing has higher pressure. That pressure difference creates lift, pushing the plane upward. Isn't it incredible that something as invisible as air can hold up something as heavy as a flying city? But wait, the story doesn't end with Bernoulli. Newton has his say too. As the wing cuts through the air, it pushes air downward. And according to Newton's third law, for every action, there's an equal and opposite reaction. The air pushes back up on the wing. That upward push adds to the lift. So, in truth, airplanes fly because of both Bernoulli's Principle and Newton's laws working together. Have you ever thought about how basketballs, bouncing on the ground, and airplanes, flying through the sky, are both ruled by the same law? Let's pause here for a fun experiment you can do right now. Take a strip of paper, hold it in front of your lips, and blow across the top. The paper rises. Why? Because the faster air you blow across the top creates lower pressure, and the slower air beneath creates higher pressure. That's lift, the same lift that keeps a Boeing 747 in the sky. Isn't it wild that such a simple trick explains such a massive phenomenon? Now think about this. A fully loaded jumbo jet weighs nearly 400 tons. Can you picture the amount of lift required to get that into the sky? It's like lifting 70 elephants at once. Yet, it happens every day. Doesn't that give you goosebumps about how powerful nature's laws truly are? But wings alone aren't enough. The airplane also needs engines to move it forward. Engines provide thrust, the forward force that pushes the plane through the air. Without thrust, no air would flow over the wings, and there would be no lift. This is why gliders, which don't have engines, must be launched from a hill or towed by another plane to gain speed. Once moving, the wings create lift, and the glider can soar, but it always needs that initial push. And it's not just about going up. Pilots must constantly balance for forces, lift, weight, thrust, and drag. Lift pulls up, weight pulls down, thrust pushes forward, and drag resists backward. Flying is all about keeping these four forces in harmony. Doesn't it feel almost poetic that an airplane is held up not by one force, but by a perfect balance of four invisible ones? Now, let's talk about something called the angle of attack. If the wing is tilted slightly upward as it moves forward, it deflects more air downward, creating more lift. But tilt it too much, and the airflow breaks apart, creating turbulence. This is called a stall. When a plane stalls, it loses lift and can drop rapidly. Pilots train for years to master the delicate balance of speed and angle. Next time you feel a sudden bump on a plane, remember, it's the delicate physics of airflow adjusting around those wings. Birds figured this out millions of years ago. Their wings are naturally curved, creating the same pressure differences as airplane wings. Watching a bird glide across the sky is like watching physics in its purest form. Isn't it fascinating that we borrowed nature's design, scaled it up, and added engines, and now we can travel across the globe in hours? And what about emergencies? If an airplane's engines stop mid-flight, does it just fall? The answer is no. Because of their wings, planes can glide, sometimes over 100 miles, depending on altitude. Pilots practice gliding landings, so even in the rarest emergencies, the laws of physics give them a fighting chance. Doesn't that make you respect those wings even more? Let's also look at altitude. The higher a plane flies, the thinner the air becomes. With fewer molecules, it's harder to generate lift. That's why planes need long runways at high-altitude airports to build up enough speed for takeoff. And that's why there's a ceiling to how high airplanes can fly. Isn't it humbling that even with all our technology, we're still bound by the limits of nature's atmosphere? And then there's speed. At low speeds, a plane needs large flaps extended to generate enough lift. At high speeds, those flaps retract to keep drag low. Every part of the wing is designed to handle airflow at different stages of flight. Next time you watch out the window during takeoff or landing, notice the wings moving and adjusting. Isn't it amazing that all of those tiny adjustments are just physics in action? When you combine all of this, Bernoulli's Principle, Newton's laws, thrust, drag, lift, angle of attack, and wing design, you get one of humanity's greatest achievements, powered flight. Whether it's a paper airplane, a glider, a jumbo jet, or even a spacecraft re-entering Earth's atmosphere, the same physics apply. So, the next time you sit inside a plane, look out the window and see the wing slicing through the sky. Remember this, what's holding you up is not magic, but the elegant, invisible rules of nature. Every second, billions of air molecules are rushing, pushing, and balancing forces just right to keep you aloft. Isn't it mind-blowing that every flight you take is really a live physics experiment happening right outside your window? And now, let me leave you with one final question. Knowing how airplanes actually fly, that it's all about physics and balance, does it make you feel safer the next time you travel, or does it make you even more amazed that something so heavy can ride on nothing but air? Share your thoughts in the comments, because your perspective might just inspire someone else to see flight in a whole new way.